You go from 512 to 1024, it takes 4 times as long per scan, right?
It's actually only twice as long.
Oh, it does only
So
twice.
so the scan speed here is the number of lines per second that we're reading. So right below that format is the speed, and that speed is in lines per second. And so what it will do as you move from 512 by 512 to 1024 by 1024, it's going to keep the number of lines it's reading, like the speed at which it's reading lines, the same, but it's going to divide that line into twice as many pixels. So the exposure time at each pixel will also be cut in half. So that's how it's not 4 times as long. You're covering 4 times as many pixels, but you read each pixel for half as long.
Okay, so exposure goes down a little bit. Okay. Which you could compensate by increasing laser power or gain.
Yes. And
if it's yeah.
In standard mode, it automatically changes that gain to keep the image the same brightness as you change either format or speed.
Okay.
If you are in counting mode where intensity units equal photon counts, then it's not automatically going to change. Like it applies the correction scaling factor to the image as you make those changes, unless you're in counting mode where a photon equals an intensity unit, and then it can't make any changes for you.
Okay.
So if we look at the pixel dwell time right here, if we change that format to 1024 by 1024, which I might have you do because it's probably going to take it a few seconds to pop up on my screen.
Oh yeah, it dropped by half.
It'll drop by exactly half, or very close to half, just because it's reading twice as fast. So
right. Okay.
And then the same with the speed. If you're changing the number of lines it's reading per second, it's going to be changing your pixel dwell time or the exposure of each pixel.
Okay, let me take control. So if I go to 800, that means, well, 700, which is about 12, that means that the pixel dwell will go down even more. Yeah. Yep. But if I go to 200, that means it goes back up to the original pixel dwell on 512.
Correct.
Okay.
But yeah, so if you went from 512 to 1024 and moved your speed from 400 to 200, you get exactly the same dwell time and 4 times as long for each image. So there's lots of things changing. Luckily, it's doing all of those calculations for you and kind of displaying what's going on in the little numbers here on the left. The other thing that comes into this is that format, like selecting what format you need. You need enough pixels to see the detail and what structure you're interested in. Like that's the real key, is do you have enough pixels to see what you want to see? If you're looking at nuclei and just trying to count cells, 512 pixels is probably enough, unless you're at a really low mag objective. If you're trying to look at the structure of mitochondria in a cell culture like dish, you're going to need as high a resolution as you can get to look at some of the small organelles and things.
Right.
In which case you're going to want to be on the high mag objectives and kind of pushing that to the limit. If you want to go all the way to sort of the Nyquist sampling limit, which is the highest the highest resolution that the objective can do, the button just to the left of format, the little circle there, if you hover over that, it will pop up a set format to, and will tell you what the maximum is currently. If you click on it, it will actually set the system to that format.
Okay.
Which for this is at what, 5,000 or 6,000-ish?
It's only 3,600.
Okay.
Is that because we're on a 10x?
We're at the 10x, and I guess the zoom, the zoom factor is at 1.28 right now. So we've zoomed in. When you went up to a speed of 700, it actually forced you to zoom in a little bit.
Well, that's where the zoom came from. Okay, I was wondering why that changed.
So the 600 is the fastest it can go at the full field of view. If you go any faster than 600, it forces you to zoom in just a little bit.
Okay.
And the faster you go beyond 700, if you go up to like 18,000 or 1800 on the speed, it forces you to zoom in a lot more. You can also zoom out past 1. It can go to 0.75. Why we didn't pick 1 as 1 is like we started at 0.75 because some of the other competitors had zooms below 1. Our system, you can run it from 0.75 up to, I think it goes to like 48 or something. It'll be fine anywhere across the full zoom range. And now you changed the zoom a little bit. So if you go back to that button, it will actually have a different number of pixels because we have a different field of view.
Gotcha.
So it's all smart. It knows, it's looking at the exact field of view. It's reading the objective that you're actually using and knows the settings for each objective. Everything like that. It all optimizes it based on your current settings. Now, would I ever recommend taking a 4K by 4K image using the 10x? Probably not. If you need that resolution, go to a higher mag objective, unless you absolutely need the field of view to be that big. But you could also do tiling with a higher mag objective as well.
Right.
So,
does Leica, does the software tile?
yes, this software will tile. So the other thing here, let's set it back to 512 by 512, and just so we aren't waiting too long for this to take an image, and then just hit live to get that running. And my video is definitely a little bit delayed, but
should we change objectives?
nope, let's stay on this one just for right now.
Okay.
And then you see the zoom in slider or the zoom factor slider there. If you either mouse wheel on that and slowly increase. The other thing is you should have a control panel right under the monitors with 5 or 6 dials on it, 6 dials.
Yeah. Oh, there's the zoom. Yeah, totally.
Zoom is there. If you just spin that one to the right, it'll actually zoom us right in on the center of the image.
Okay.
And there's quite a few controls on that dial, and that dial is actually customizable.
Yeah,
so
zoom, pinhole, smart offset, and smart gain. So that can't be seen by students on Zoom.
Correct. They will not be able to see or use that to run it remotely. But someone who's sitting at the system, it's really nice.
Oh, absolutely. It's great for me. I'm just remembering that I'm going to have to learn what you're showing me on the screen first.
Right. And so all of those things controlled with those dials are in the software somewhere. Let's see if I just want to stop it real quick and show you where most of those are. Okay. So that dial or that control panel, you can actually bring up the settings for it right here with this button. Okay. And you can change what each of those knobs does, and then below it, you can change how fast each of those adjusts it. So if you want to program them to anything different, there is one that's not programmed to anything right now. If you click on that, there's a whole list of various options of what it can be set to.
Okay.
So we can.
That was this thing right here.
Yep, that button tucked away behind there. It sort of shows a picture of what that control panel looks like. So, whoops.
This software is so much easier on the eyeballs and the brain than the old Nikon Elements, which it was I don't know if you've used Elements. It's a gazillion buttons, and they're not very well laid out. I mean, they've probably changed it to make it better now, but
Yeah.
I like this layout.
Yeah, Leica has done a very good job making their software fairly simple and easy to use. And as we were going down, so let's go live one more time here, and I'll let you drive for a second. And under that zoom factor slider in the software, I'd actually click live first. Is it live?
It's live.
Okay, so that zoom in button,
Yep.
click on that, and then draw a box on the image around what you want to zoom in on. So just pick somewhere and wherever you draw a box and let go, it'll actually zoom us in right to that area.
Okay, is it going to only take pictures of that, or is it?
Yes, it's
okay.
only imaging that area. And it's a true kind of optical zoom where it's putting those 512 pixels in a smaller area. The density of those pixels has gotten higher.
Okay, cool.
And it's
the
same.
The double neurons. There's like two of them for each of these. It's a rib cage, which are the projections, but then you can see one neuron, two neuron, one neuron, two neuron.
Yep.
Cool.
And so right next to that zoom in where you just did that, now there is an undo arrow where if you want to zoom back out, that will take you back to the previous zoom level.
So the zoom in just gives you a one-time chance to do it and then goes back to off.
And if you click it on again, you can zoom in further. So you can actually zoom in multiple times and just get smaller and smaller each time.
Oh, you mean you can do it again?
Yep, once you've zoomed in there, you could actually click it back on and zoom in further on one of those sort of pairs of neurons or something. It doesn't.
Oh, but the reset only remembers the last one.
Correct. But you do have that whole zoom factor slider where you can just slide it to the left to move all the way out.
Gotcha.
Or spin the dial on the thing in front of you. However,
right.
Students will have to use the slider in the software because they can't manipulate those dials.
This one works better. This one goes, the zoom I can change by 0.01 with this dial, but the mouse jumps by quite a bit. Okay.
Right.
You can type it in. That's okay. All
yeah,
right.
You can double click and type if you want something specific is the so when you are zoomed in, the arrow keys, so if you see the circle with the arrows pointing in all directions, just down a little bit below the zoom factor, right there. When you're zoomed in, those can actually shift. It's not moving the stage, but if you were off just a little bit in where you zoomed in and you wanted to kind of just adjust where that zoom in window was a little bit, you can click on those and it will shift the image around. But it cannot go outside the original field of view.
Right. Okay. So if you don't mind, let me just sort of recap or extrapolate. The purpose of the zoom is you get to maximize your pixel count for whatever format you're in, which means if you have the objective you want, you've got two choices to zoom in. You can go to a higher objective, or you can be on the objective you're on, like now 10, and just zoom in, and then it maximizes the pixels on that area, which is better than just taking the picture as is and zooming in on software later, because you're losing resolution if you do it that way.
Right.
Okay.
And I mean, the other thing is if you're only interested in a small portion of what you see, you don't have to spend the time to collect pixels everywhere else.
Right.
Only put pixels on the exact feature that you need.
Is it only going to put the laser on those pixels too, so it won't bleach other pieces?
Yep, exactly.
Cool.
But the other part of that is when you were looking at the entire field of view, you were spreading that laser power out over the entire thing. If you take that same number or same amount of laser power, you're concentrating it into that tiny little area you zoomed in on. You can actually photo bleach much faster by zooming in.
Oh, so that's the same thing as with different lenses. As soon as you go to a higher objective lens, you bleach stuff.
Yep.
Right. Literally focuses it. Okay.
Yep. And that's what, I mean, that's what this is doing too, is it's just spending more time on a smaller area, same amount of laser, it's more likely to bleach.
Okay.
And you'll see that if you zoom in on something that's sort of labeled or sort of full field of labeling, you zoom in a lot, you take a bunch of images. As soon as you start zooming out, you'll see the exact square you were imaging that can be bleached.
Ooh, that's good. We have a thing called Project Bleach too, which is sort of on purpose bleach something.
Mm-hmm.
So that's cool. I'm like, go pick a neuron and bleach it. So then they'll take one big picture and then I'll have them use the Zoom software to go in, bleach it, then come back out and say, see?
Yep.
Okay,
Zoom in,
cool.
crank the laser up, it'll bleach pretty quick.
Yeah, okay, neat.
When you're bleaching, have them use the PMT rather than the high D, just because when you're cranking the laser power up to bleach.
So we don't ruin the ID free.
Yep.
Right.
Other things are there's line averaging, frame averaging, line accumulation, frame accumulation. Averaging will read the image twice and just average together to help get rid of noise.
Right.
Accumulation, it's just adding it together. If you have really dim signal, you can just read it a few times and add it up to build up signal. Doesn't get used too often, but can. Line, it reads the same line immediately twice or however many times. Frame, it reads the entire image and then repeats that. If it's like Z stacks, it will repeat.
It goes through the whole thing and then goes through the whole thing again, whereas line just does 1, 2, 1, 2.
Yep.
Okay.
The frame, it's if you have a whole Z stack set up, it will read each plane of the Z stack before moving to the next plane. So it will read that same plane like 3 times and then move to the next one 3 times for the frame averaging. But that's what those settings are. Obviously, if you do a line average of 2, it's going to take you twice as long to image because it's reading each line twice.
And potentially bleach.
Yes, and bleach it twice as much per image. Like all of that, you're just doubling everything basically. But if you have a noisy sample and you want to keep the laser powers lower to prevent bleaching, you have more noise, but you can average to get rid of some of it. So there can be trade-offs in a few different places. Other thing with lines is there you can also, by default, it's reading from left to right, jumping back to the beginning, reading from left to right, jumping back to the beginning, reading from left to right. Every line is read from left to right. You can tell it to zigzag through the image. So that's what that bidirectional just below speed is here. If we turn that on, it's going to read left to right, right to left to right, right to left as it goes down the image.
Does that have an effect on the image or does it just make it faster?
So it depends on the age of your system, actually. Yeah, it makes it twice as fast with no effect on the image.
Okay, that seems like one I probably want on all the time.
Yep, it's free speed. The only downside is you then have a phase, which is the alignment of things that are read from right to left and left to right. So if we go live here, the phase is at minus 32.11. If we go live, I like to come over and mouse wheel in on the right-hand image, which is a purely digital zoom. So that's not changing pixels or anything. This is just blowing up the raw pixels that we're taking. And then if you, and actually let's do it this way. I'm gonna make phase be one of the controls here.
Okay.
It's a lot easier to control with that. And now if you spin that phase dial, you'll actually see the image separate, where you can see lines that are read from left to right and right to left are not overlaying properly if the phase is off.
Okay, interesting.
Whereas if you adjust the phase to where it's perfect, you won't see any of that zigzag at all.
Okay, so does it know where to make it perfect when you do it?
So it's a calibration that the service engineers do. But if there's big temperature swings, if you zoom in a whole lot, there are some things that can actually make it not stay perfect. I'd say 99% of the time, it's not something you have to worry about at all. But if you ever see that zigzag pattern along the edge,
right? Okay.
Just be aware that that may be what it is. If you see it, you can sit there and try to adjust the phase to make it perfect, or you can just turn bidirectional off and it will be completely gone.
Okay.
Like if bidirectional is not on, you don't have to worry about it at all. But if it is on, like there's always the chance that you could get slight artifacts there. But it is basically a free doubling in your speed.
Although to be honest, this is so fast so far. I don't know if I'm going to care about the speed so much.
Right.
I mean,
if you're going to high formats and multiple colors and things, it can actually slow down.
Right.
But that's what bidirectional is. I think I clicked on stop.
You did.
And make it. So it's just taken a little longer than I'm used to update.
Yeah. So how is the video and the talking between us?
So it all sounds good and the video looks really good. It's just there's quite a bit of lag between one of us changing something on the screen and me actually seeing it update on my screen.
Okay. Because that'll probably happen with my students too. But I'll just make sure we're patient with that.
I was gonna say that it will make it tricky for them to control a lot of it just because you have to click and wait and see what it actually does.
Right.
Is there?
But I can also just have them tell me what to do, and they can. That's not even necessarily bad if they have to keep saying the words.
Right.
You know, because the more you say the words, the more it clicks in that that's what it is.
Mm-hmm.
Sometimes I can memorize how to click things and not even know what I'm clicking. I just know where it is.
Yep.
You're like, click, 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 click. You know what to do. And then if they ask you what you did, you're like, I can't quite remember. It's the thing on the left below the zoom, right? You know?
Yep.
So, because like I was saying, learning this and teaching it is different than being in a lab where you're just doing one thing all day.
Yep, exactly. And so
pinhole size, oh, there it is. Before, oh, you hit on the pinhole. Okay.
Yep, you just click on that and it drops down. It automatically always sets it to 1 area unit, which is what you want. As you change objectives, it's actually changing the size of the pinhole for you, but it is maintaining 1 area unit. You can adjust it off of that just by, there's a dial on that control panel or by moving this slider. If you want them to simulate what a wide field image would be like, you can open up the pinhole.
Right, okay.
Running it fully open will be very similar to a wide field microscope. what running it sort of close to 1 area unit is going to be. Again, as you open that pinhole, it's going to get a lot brighter. Maybe do that on a PMT, not the high D.
Okay.
If you get really dim samples like your calcium imaging, yeah, it can certainly help to open it up, but otherwise, most people leave it. Z-stacks, you're probably pretty familiar with those and how to set it up. There's buttons to set a beginning and an end.
Yep.
So we can go live here, and then if you want to move.
Okay, so, but I'm trying to think, if the student's doing it, they're only
student's doing it, you want them to do it in the software, where, like, basically, what could I do to do that?
Right, which would be
The
this.
easiest thing to do is to position the mouse on top of this little diagram here, which is kind of the objective there, and use the scroll wheel to go up and down.
Okay, cool. Well, I'm glad you were telling me. Okay.
Yeah, most people don't even know that works, but that will actually move the objective up and down.
And by big jumps, it's going up by 22.
Yep, it's pretty big. So this plus button right next to Z wide there, if you click on that, it will bring up a slider that will adjust the sensitivity. And if you drag that just a little bit to the left, you can actually make that step much finer. The thing you do have to be careful of is if you click and drag in that window, you can move the objective very fast, very far.
Okay, that may have been what you were telling me. You can do it, but you also, there's ways of ruining it.
Right. So if they were focused on a slide and then accidentally clicked and dragged, they could just drive the objective straight up into the slide very easily.
Right.
Which on an inverted system isn't as dangerous, because the slide will just pop up.
Pops it up, right. The other way, it just crushes it, and then you're doomed.
And I have had people crush it on remote. Like, I have seen remote systems crush slides on uprights. Inverteds are very much safer.